When you stand on a beach and look at the horizon, that endless blueness that greets you, is it the reflection of the blue of the sky in the water? Or is it the color of the water itself? When you fill a glass with water, it looks completely transparent. But how does a vast ocean take on such a rich and deep blue? The secret of the ocean's fascinating blue is not a simple reflection, but the story of a complex interaction of light with water, a process of selection and scattering. The answer to this question was given for a long time simply as the reflection of the sky. On a calm day, the surface of a lake does indeed reflect the sky like a mirror, which contributes to its blue appearance. If the sky is gray and cloudy, we notice that the water also looks grayer and more colorless. So yes, reflection plays a role. But it is not the whole story. If the ocean were just a mirror, it would not explain why you still see that blue when you look at the bottom of a pool or down from a boat. The ocean has its own inherent blue. To solve the secret of this blue, we must remember the white light that comes from our hero, the sun, and its colorful spectrum. White light contains all the colors of the rainbow: red, orange, yellow, green, blue, purple. When this light beam hits the surface of the ocean, its journey begins. Water molecules interact with different colors of light in different ways. They are especially good at absorbing long wavelength colors such as red, orange, and yellow. As the light enters the water molecules absorb the energy of the red light like a sponge and convert it into heat. For this reason, the red color almost completely disappears even at a depth of only 5 to 10 meters. When you go a little deeper, the orange, then the yellow and green colors are also absorbed and disappear. For this reason, in deep-sea documentaries, you notice that everything around you looks blue-gray unless the divers use their own light sources. What about blue light? Short wavelength colors such as blue and purple are not absorbed that easily by water molecules. Instead of being absorbed, they hit the water molecules and scatter in all directions throughout the water. Just like the ball in a pinball machine, blue light photons bounce from water molecule to water molecule and scatter in all directions throughout the water. This is the secret of the ocean's blue. When we look at the ocean, the light that reaches our eyes is not absorbed by the water, but is scattered in all directions and returns to us. The ocean works like a color filter. It absorbs red and yellow tones and reflects and scatters blue back to us. The deeper and purer the water, that is, the less particles such as mud and algae it contains, the stronger this effect is, and the deeper and brighter the ocean appears blue. That turquoise color in the Caribbean or the Maldives is usually due to the shallow water and the white sand bottom reflecting more light. Sometimes we also notice that the ocean looks greenish. This is usually due to the abundance of microscopic plant life in the water called phytoplankton. These life forms contain the pigment chlorophyll, which is necessary for photosynthesis. Chlorophyll absorbs red and blue light while reflecting green light. This is why waters rich in phytoplankton tend to appear more green than blue. Ultimately, the color of the ocean is a result of the dance of light with the water. It is not simply a reflection of the sky, but a reflection of the water's ability to select, absorb, and scatter colors. That deep blue you see when you look out into the ocean is actually the triumph of the one color that survives and reaches your eye after all the other colors of the light spectrum have been lost in the depths of the water: blue.
The Door to Knowledge, presented by Toyer TV. Don't forget to take your place on this path of discovery and enlightenment.